Welcome back. I have here a box full of parts and some plans. But what's the saying? The best laid plans of men and mice often go awry. So wish me luck. The plans are of course for a laboratory shaker. And here's the basic idea. You have a fixed bottom part and then a top part that can pivot around an axle that goes through both parts. The whole thing will be driven by an RC servo, which is screwed to the bottom part, and the servo arm is connected via a push rod to a second smaller axle that goes just through the top part. Most of the circuitry and practically all of the software I need to control the servo I've already done in the three-parter motion control with RC servos and microcontrollers. Card to the first part here and links to all three parts in the description. That is the core circuit with the debouncing of the rotary encoders I developed in the video Hardware Debouncing with MC4490s. Card here, link in the description. And the whole thing is of course intended to shake my laboratory water bath. Card to the playlist here, link in the description. That's the circuit diagram for the laboratory shaker. Compared to what we've already done, I switched out some pins around the debouncing chip and the Arduino just to make layout easier. I added a power LED and of course a power supply. 9 volts for the Arduino and 5 volts for the servo. Of course, I have a layout for the circuit board, and the whole thing should go into a case from Bahar, the BDH 210, that little guy here. And that case is in fact the little brother of the case I already used for the laboratory water bath. Let's first verify if the circuit is really working with the power supply and the LED, of course. I will also have to change the software a little bit, just the I/O pin definitions. I won't show you that, but I mentioned I swapped out some pins for, layout reasons. I changed the connections on my breadboard to match those in my circuit diagram. I added the power LED. And I changed the pin definitions in my Arduino sketch, and everything seems to be working just fine. And I really just changed the pin definitions here in the software. That's why you have pin definitions. Let's tackle the power supply part. It consists basically of a connector, a fuse, which I won't put on a breadboard, a 10 watt AC-DC converter, 5 volts, which will supply the servo, and a 1 watt 9 volt AC-DC converter, which will supply the Arduino, which in turn supplies the digital 5 volt rail on the board. The reason I'm not running the servo of the Arduino Nano Every is that the servo might, according to the manufacturer, draw up to 1.2 amps. Other reason, the servo, with its motor is a very, very noisy load, and I don't want to have that load on my 5 volt digital rail here. Okay. Let's do it. I've placed the two AC to DC converters here on two separate breadboards. One breadboard for the mains AC side, the other breadboard for the low voltage side, so we have good isolation. And you can see the 10 watt brick delivers 5 volts for the servo, and the smaller 1 watt brick delivers 9 volt for the Arduino. So let's connect that to my main breadboard and see if everything's still working. And it does. Wonderful. So yeah, everything's fine. Anyway, let's move on to the layout and the casework. There's really nothing special about the layout. I mean, you have a low voltage side here and a mains AC side here with a nice big separation for isolation. Single-sided as always. Big ground plane here, and the only special are these very fine traces here, 0.35 millimeters between the legs of my debouncing chip. I hope that will work out, but we'll see. Of course, we should check if my layout, I printed it here in the scale 1:1, is fitting into the enclosure. And we'll do that right now. Looks good. And yeah, also the mounting holes, I tested that they are all lining up perfectly. So no worries. One more worry, or one thing we should check, because I have here a power switch at the front, but yeah, that's not interfering with that AC to DC converter. And I have an even bigger part, the power inlet here in the back, but that's also not interfering with the fuse holder, or is it? No. Enough space. I mean, just that part that's coming in here, and yeah, there's enough wiggle room. Perfect. I also have a drill plan for the back and front plate. But to verify that, I first have to have my board in the case to see if, everything is really, I mean, I know this is lining up, but does it line up really in height? We don't know. We'll have to see. So the next step would be to make that board a reality, solder on all components, and then check again if it still fits into the enclosure. And after that, check the drill plan for the front plate again. Till then, bye.